Section 2, ionic bonds and ionic compounds. Okay, an ionic bond is an electrostatic force that holds oppositely charged particles together in an ionic compound. The example that I have here, this is sodium and chlorine. So, where's my mouse? There's sodium. See, it's one valence electron. It wants to lose that.
Okay.
See, chlorine, it has 7 valence electrons. It wants to gain 1. So sodium says, you can have mine. And they share, or they don't share. It gives it away.
They give.
Okay, so now we've got an electron transfer. Now we have sodium. It has an empty outer energy level. Okay, that's a +1 charge. And chlorine has a -1. There is an electrostatic attraction between the positive and the negative that holds them together.
Aw, they're buddies.
So NaCl, salt. This is how you make it. We will never make it.
No, because
Chlorine gas.
Yeah, chlorine gas is poisonous. Sodium blows up in the presence of water.
Right.
So, not a good combination.
So
for
this
our
is
little...
how you make it, and that's all you're going to see from us.
Or we're just going to evaporate salt water and we'll get the salt that way.
Right. Okay, binary ionic compounds. This is when you have 2 different elements. So it's just a single element that makes the cation, a single element that makes the anion.
Okay.
And normally it's a metallic, or always, it's a metallic cation and a non-metallic anion. So example, again, sodium chloride. Oxides. If you've got something bonded with oxygen, and oxygen is the anion, it's going to end with oxide.
All right.
So example, magnesium oxide.
All right.
Formation of an ionic compound. Oh gosh, now we have to draw.
Uh-oh.
We're going to do some Lewis dot structures and electron configuration. So first we need to, right, can I grab it like that?
Yeah, I think so.
Okay. First we need to draw magnesium.
Gee, it has a charge of 2+, which means it's going to try to get rid of 2 electrons. So we're going to do the dot structure. 2 dots, 1, 2.
Okay. Do you want me to do another color for oxygen? Is that how you
Oh,
want
it's up to you. I'd love to see another color, but it's kind of a pain.
Great.
Ink color.
Can we do the yellow?
Ooh, yellow.
Yellow.
Nice.
Thank you. Okay.
Oxygen.
Oxygen.
Wow.
Whoa.
Like the yellow. Oxygen has 6 valence electrons. So it's got 2 open positions.
Just go away. Okay. Sorry. Okay. Now we are going to take these 2 from magnesium and give them away to oxygen because magnesium doesn't want them anymore. Oxygen does. So we're going to take this guy and move them right down here. Okay. Octet rule, it wants to have 8. Magnesium wants to get rid of its extras so that it can also have 8. So you're going to put them right there.
Okay.
Okay, that's an ionic compound.
All right.
Now they will be electrostatically attracted to each other.
Aww.
Okay,
Buddies.
magnesium and chlorine. So magnesium still has 2 valence electrons. Okay. The chlorine.
You are getting really good at this.
Good.
Really.
Okay. Chlorine. How many valence electrons does it have?
7, 2, 3, 4, 5, 6, 7. Wait a minute. So chlorine only needs 1, but magnesium has 2 to get rid of.
Right.
Now what are we going to do?
Well, what's the charge of magnesium?
It's a 2+.
Right. And what's the charge of chlorine?
It's a -1.
Right. So
They don't match.
we need to make it neutral. So how many chlorines do we need?
1 more
Yes.
for a total of 2. We can't just bring in any other element.
Nope.
Oh, why not?
We make a whole different compound, silly.
Oh, are you sure?
Yes.
Okay.
Okay. I'm concentrating.
I know.
Stop messing with
I'm
me.
trying.
Okay, so that's going to be your ionic compound of magnesium chloride. You've got 1 magnesium to 2 chlorine. So if you were to write the formula, it would be MgCl2.
All right.
Okay, and up here you would have MgO. And we'll get into writing formulas a little bit later. So properties of ionic compounds. They form a crystal lattice. So this is mostly in your binary ionic compounds. You're going to
Yeah.
see pretty much they alternate every other
Mhm.
one. It just depends on the structure of your compound. But like down here, you have an example, lithium and chlorine. Every other one is going to be lithium. They're going to be surrounded by chlorines, and chlorines are going to be surrounded by lithium. So normally you see this nice cube structure. But it's a three-dimensional geometric arrangement, and yes, they're surrounded by the others.
All right.
Physical properties, they have high boiling and melting points. The hardness can vary,
Okay.
and they can be brittle, or they can be very hard. If they're very hard, they're not brittle. So it depends on how strongly the particles are actually attracted to each other. This has to do with how large is their charge, the positive and the negative, and how close are they actually held together with that
Mhm.
electrostatic force. So when they melt, so if you take a solid and melt it down to a liquid, they will conduct electricity. Electrolytes are when you take that compound and then you dissolve it in water. So if you make an aqueous solution, we haven't covered that term yet, have we?
We talked about it a little bit.
Okay. If you make an aqueous solution, they will also conduct electricity. But in the solid state, they are not going to conduct electricity. So you can't put one of our little conductors on a solid piece of salt and expect it to conduct. But if you dissolve it in water, it will.
And we dissolved it in water, and that became our aqueous solution.
Exactly.
All right. Sweet. Oh, I was going to try. Okay.
Lattice energy. So when ionic bonds are broken, energy is released. It's not necessarily, we can't see it. We're not
No.
really going to be able to measure it very well.
So my psh didn't really.
It's like,
Oh, man.
but lattice
All right.
energy is the energy required to break the ions apart. So we're talking at the atomic level.
Okay.
So the stronger the attraction is between the ions, the greater the lattice energy. So if they are really held together tightly, it's going to take a lot more energy to release them from each other than if they're just kind of hanging out nearby
Okay.
each other.
Makes sense.
This is related to the size of the atoms, and it's related to the charge of the ions. So if you have really large atoms, or if you have a really large charge, it's going to be a stronger attraction. You're going to have a higher lattice energy.
Okay.
Okay? Now, which one has greater lattice energy? You have sodium chloride, or you have magnesium oxide. How are we going to figure this out?
Well, there's two different ways. We could do a little math, or we could take the easy route and look in our book in a chart.
Yay!
So on page, look how handy I was. 271 in your book, there's a nice chart. You can look up the different numbers, and the higher one, bigger number, greater energy.
Okay, so in our book, Table 7.6, it says sodium chloride has a lattice energy of 769, and the magnesium oxide is 3,795. So
Big difference.
the one that has the greater energy, I'm just going to circle it for you, magnesium oxide. Okay, the other way that you can do this is look at the charges. Sodium has a positive 1, chlorine has a negative 1, magnesium has a positive 2, and oxygen has a negative 2. So the ones that have the higher charges, they're going to have the higher lattice energy.
All right.
Okay, that is all for section 2. See you tomorrow.